Hello, this is Trevor. Today we're working on another CSRF lab in PortSwigger's Web Security Academy. This time it's a CSRF with broken refer validation. So it's in the email change functionality. The detection mechanism can be bypassed. We need to change the victim's email address. And then we have credentials we can log in as. All right, cool. Let's get started. Please remember to like and subscribe. Let somebody know about this content if you think they would appreciate it. All right, it's in the My Account. Let's log in there. Wiener Peter. And then the change email functionality. So we'll do, let's make sure we're, there we go. new@email.com. Did that. Let's go check it out. HTTP history. There we go. Let's send to repeater. And we'll send this so we have a baseline. And notice how we don't see any CSRF cookie, nor do we see any CSRF token. So, but we do have the refer header. So let's try just replacing this blah.com. See what that does. Invalid refer header. Okay. So that did not work. What if we do .blah.com? That worked. So what I imagine is that if I think of the code on the other side, it's checking to see if this string exists in the refer header. If so, it succeeds. If not, we get the invalid. So as long as we have this string, we should be good. Let's try to test that. I'll do blah.com and we'll do question mark A equals. And then I need that string again, which is right here. 2. We'll paste that right there. And we'll send with 1. That looks like it worked. Let's verify. We're looking for a 1. There it is. Cool. So that's how we're going to exploit this one, is just basically send this URL. Let me do one thing. So I'm thinking ahead to the script. The script receives the URL as a parameter and then does that normalizing. So I want to check, what if it was the full normalized URL with HTTPS at the beginning, the 2 forward slashes, and that end slash. Will this still work? Let's put in 2. Otherwise, I have to kind of trim this up. That looks like it worked. And it did work. Sweet. So that's how we'll do it. It's not a big deal if it didn't work. I mean, you know, we could just split on the forward slash and make sure we get this one. You know, just this part. But if we don't have to, we don't have to. So, sweet. Let's start with the code. This thing is named refer validation broken. Vim referrer validation broken.py. And let's grab, what do we need? We need something that let's do no defenses. This looks good. This looks like a good starting spot. We need, okay, so if we look at our study sheet here, we're in the refer header one, not this one, right? We tested this second type right here. So we need to make sure the header includes unsafe URL. if we go to here and take a look at the exploit server, we can see that we can provide header information. Let's make sure our script is set up to use that. That'll be in site post exploit. Yep, sure is. So we just need this in the response heads. We need this whole line. Let's just copy that, and we're gonna put this here, and then we're gonna add to the end of this a /r/n, and then that header that we just talked about, which was this one. Paste that there. That looks good. Let me shorten up this line so it's not going to give us any problems. So I'm going to put a parenthesis. Do that. Let's do another parenthesis here. So I'm going to double quote, enter. Sorry, not parenthesis. I'm going to remove this comma from that was left over. Perfect. That looks good. We got our payload, which is going to be boom, boom. That looks good. Post exploits, we need the response body. We also need the response head. And I'll double check that, but equals response head. And just to double check, post exploit, response head. Yep, that's what we need. So that looks good. I think we have it. Python refer validation broken. Let's go get the URL. This one. Paste that. Send it. And survey says uh-oh. Dang, we did not get it solved. Why not? Oh, after all of that, I forgot to include. So did we not do this right? We need. Dang it. We need to have this be in the refer. So we want to change from exploit to the question mark, whatever, right? I think that's right. Let me tell you what I'm thinking. So here in the exploit server, right now we're getting this file. Instead of this file, we want question mark that URL for the website. Yeah, pretty sure that will be it. So let's go here to the repeater and get all of this copy. And we'll close this one. Go here. Response file, that's the one we want. So response file equals, we want /exploit, let's do /. I think the default, yeah, /exploit. We don't need this, but I like it, so I'm gonna keep it. This slash right here where my cursor is what I was talking about. Okay, so we have a response file now. We need to make sure that we include that, and we'll do it in the beginning. So response file equals response file. There we go. Okay, this time I think it'll work. Everything else looks right to me. Uh-oh. Dang it, what happened? So, we've got the referrer policy, unsafe URL. Do we need a semicolon? No. We don't need a semicolon. We've got the response file, which is this, so that means that's its URL. And then we're delivering the payload of this, which is going to auto-submit the form. That all looks good to me. Let's go see, how do we view the logs? I want to open that new page, but whatever. Okay, so this is a get, whatever, user agent delivered a victim. So this is the victim, and they got the exploit first, which is fine. Uh-oh, this double slash, the end. I don't know if that's causing the issue, but they did post. See this last post? And they got a 302. Did they post it to the right? Form action. Method post, blog, change email. That looks right. But let's remove that trailing slash. Try it again. No. Okay. Let's remove this slash. Question mark is correct. No. That A equals maybe? Or maybe it needs to be URL encoded. Let's try that. So A equals, so this, so let's do URL equals, and then this is the part that may need to be URL encoded. Everything else should not be. From URL lib dot parse import quote, and then here we want F here, DT double quotes. We want URL there. Let's try that. Oh, sorry, I didn't use quote. Dang it. Let's view it ourselves now. Back to exploit server. I want to view exploit. So let's see what happened. Proxy. So we got the page with the URL. And then we got the form in that URL. The indent is a little bit off. Form, end form, script. I don't know why this script is off, but whatever. That doesn't matter. Then it posted with the refer that included this. Let's copy this and go to repeater, and we'll paste that here and see if it actually worked. If this works. So we want change to 3, send. That looks like it works. And look, our payload worked. We just don't have it. Oh, it may be solved. No. New 3 worked. So everything worked. Why don't we have it solved? Access log. Post. It got it exactly how we wanted. It's annoying. Maybe we can remove the /exploit and the A equals and just do / and then this. Maybe. So, in order to put that change into motion, we're going to do delete this. And maybe it's even the question mark. What if it's just a page? Problem is that it worked when we viewed it. It changed our email. So if it worked for us, I don't know why it's not working as our exploit. There we go. Ooh, got it. So the question mark, once I removed that, it solved it. Which is silly. Question mark shouldn't have prevented it from being solved. And didn't. It worked against us. So I'm not sure what the deal is there. But let's go there. Congratulations, we solved it. Woohoo. All right, just to recap. We saw that when we were sending the post to change email, it did not include any CSRF cookie or any CSRF token within the body of the post. We tried changing the refer header to another domain, but on its own, that returned an invalid refer response. We then tried to put the original domain at the beginning, so it was this.net.blah.com, sent it, and it worked. We then tried to put it at the end of the refer, and again, it worked. Once we had that part, that was going to be our exploit. So we set a variable called URL to that, the victim or the site that's susceptible to CSRF attacks. We set up the exploit server to host a file, and when someone accessed it, it was going to be at the exploit server URL / and then this URL. URL encoded also. We had to give it a unsafe URL header in the refer policy, and that's to make sure that anything after the question mark got transmitted. We ended up removing the question mark, but hold on, I'll get to that. And then we set up our payload. Our payload is similar to what we've used in the past. With all of that together, we submitted it to the exploit server and told it to run with it. When the victim viewed the page, it would be at slash the vulnerable website URL. They would receive the header, and then the form would get automatically submitted through JavaScript with the values that we had entered. The trouble we had was we had this response file URL kind of much longer than what it is now, and it looked like the question mark was our issue. So once we got rid of that question mark, it suddenly got solved. Although it looked like it should have been solved way earlier, based in part because, you know, we viewed the exploit on our own and it changed our email address. So if it works against us, it should have worked against the victim account. But nonetheless, we got it figured out. And that's it. So this is cool. So right now, as I'm filming this, this is the last CSRF lab. And I don't honestly know what we start on next. Let's take a look. Clickjacking, yeah, sweet. And that'll be a quick one, so not too much to do there. So that's what we'll start on tomorrow. All right, well, as always, if you have any questions, definitely let me know. Otherwise, I'll see you in the next one. Thank you so much. Goodbye.